So this is the second part of my Unit 9 summary. And the first thing that I want to start with is actually just to think about the equilibrium that I talked about, how we reached that in the first video, which is the level of employment and the real wage where the price setting curve and the real wage meet. And to talk about why we can think of that as a Nash equilibrium, as in an equilibrium where nobody wants to change the actions that they've taken. And after I've talked about that, then we're going to look at a bunch of different scenarios where things could take us out of equilibrium and then look at how do we come back to equilibrium. So the first thing is, why does this count as an equilibrium, right? Well, if we think about things from the firm's perspective, none of the decision makers within the firm would want to do anything differently. So the HR department, who are setting the nominal wage, right? They have chosen a nominal wage that leads to a real wage where workers are putting in effort and they're achieving that with the lowest possible nominal wage. Okay, so would they want to change that? Well, no, because if they increase the nominal wage, they're paying a higher wage, a higher cost to the firm, and not getting any greater amount of effort, because we said we assume workers in this model either work completely or don't work at all. So certainly there's no reason to pay a higher wage. They're not going to get any extra effort. Would they want to pay a lower wage? Well, no, because then the workers would shirk and they get no output. So the HR department are happy. The marketing department, who set the price, have they achieved the best thing they can? Well, yes, because the price that they've set leads to a quantity and a price that maximizes the firm's profits. So that's perfect. They couldn't do any better than that. And then from the production department's point of view, they then have to choose a number of workers that will allow the firm to produce that level of output. And if they do that, then they couldn't possibly do any better, right? They wouldn't want to hire more workers because then they'd be paying wages that are kind of pointless. They're not producing any output. And they wouldn't want to choose fewer workers because then they wouldn't be able to produce that profit maximizing quantity. So on the firm side, nobody wants to change what they're doing. Now, on the other side of this is the people supplying the labor. So the people who are currently employed, do they want to change anything? Well, the answer to that is probably not. It's definitely not. So at the moment, they're getting paid this real wage up here where the equilibrium is, and they're putting in effort. Now, do they want to not put in effort? Well, no, because then they'll become unemployed, right? Because there are some people, and these people we'll talk about in a second, these unemployed people who would be willing to take those jobs. So workers who are employed certainly don't want to suddenly not put in effort. Now, do they want to put in more effort? Well, we're assuming that they can't, right? They're putting in that maximum level of effort. So they don't want to change what they're doing. Could we ask, do they want to maybe potentially demand a higher wage? Well, again, no. So if they demand a higher wage, the firm knows they can replace them with other people. Would they want to demand a lower wage? Well, no, that just doesn't make sense, right? At the moment, they are, like, why would they want to demand a lower wage? There's no benefit there. So the employed workers they don't want to change their actions. Now, the unemployed, this is the sort of interesting group here because they certainly seem to have lost out. And actually within these unemployed workers, there are people who would at the equilibrium real wage would be willing to supply labor. And in fact, they'd actually be willing to supply labor at a lower wage. Now, be careful with this. They'd be willing to supply the labor. They'd be willing to take a job, but they wouldn't be willing to put effort in. So from the firm's perspective, do they want to hire some of these people? No, right? They wouldn't want to lower the wage and hire these people who are willing to work at a lower wage because they know those people wouldn't put effort in. So that would be a waste for the firm. So from the unemployed workers' perspective, you're thinking, well, could they be better off if they lowered their wages? No, because the firms are never going to hire them, right? The firms are not going to hire anyone below this real wage because they know that's the wage where workers will actually put effort in. Now, would the unemployed workers want to ask for a higher wage? Again, no, that doesn't really make sense because then the firm's not going to hire them either. So yes, we have a Nash equilibrium. The employed workers, the unemployed workers, the firm, everybody is making a decision which they wouldn't want to change. However, is this Pareto efficient? Well, no, because there are workers here, sorry, I say workers, there are unemployed people who would be willing to accept the job at a lower wage than the equilibrium real wage. And so there is possibly a way of changing the allocation of things to make the situation better off, to get these unemployed people into employment. So this is not Pareto efficient, but it is a Nash equilibrium. So now what we're going to do is start looking at various different scenarios that we could use kind of to explain this model. So the first scenario is, what if there is some change to the level of demand across the whole economy? And here, let me be specific, the demand for goods and services, not the demand for labor, but the demand for goods and services. So what this diagram shows is the point X. This is our equilibrium initially. It's where the price setting curve and the wage setting curve meet. And that's going to give us a level of equilibrium unemployment. So in equilibrium, we have some people unemployed. But then we're imagining that there's some sort of recession as a result of aggregate demand dropping. And that's then going to lead to firms firing some of their workers. So the level of unemployment increases, and we see it increases by this much till we get to like this level B here. And so we now have a larger amount of involuntary unemployment. So what we're going to think about now is, well, what might happen, right? We know at point B, that's a disequilibrium, right? We have a point here where there's a gap between the wage setting curve and the price setting curve. So we can't be in equilibrium. We're at a point where they're not the same as each other. So we're going to think about two ways that we could get back to equilibrium. So the first is the way that does not require any sort of government involvement whatsoever. So let's think about what would happen here. Well, we know that from the firm's perspective, when they see the level of unemployment goes up, they're thinking, well, hold on a second, right now we're paying this real wage level here, but we know that actually, now that the level of unemployment is higher, we could get away with paying a lower wage, right? We know that now there's a higher level of unemployment, workers would be willing to accept and put in effort at a lower wage. In fact, this real wage down here. So what would firms do? Well, if they're being rational, they would lower the wage. So let's have a look at the firms, and maybe particularly like the not the production department, the marketing department's choice. How is that going to change now? Well, all right, we can see two lines here. The first one, W, that's where we were initially in terms of that's what the nominal wage that the HR department would set is. But now they realize they can get away with a lower nominal wage because there's this higher level of unemployment because of the recession. So they lower the wage down to here to WL. The knock-on effect there is, remember that the wage is the nominal wage divided by lambda gives us the marginal cost here. And so now that it's lower, that's going to impact the shape of these ISO profit curves. So maybe just one quick diversion on why. Well, here the marginal cost is constant, right? It's nominal wage over lambda. And if the marginal cost is just as constant, then that means the marginal cost and the average cost are the same thing. And we know that the shape of ISO profit curves is determined to an extent by the average cost curve. So if marginal cost and therefore average cost change, the ISO profit curves are going to change shape. So this one here that says ISO profit curve initial wage, that's where we were before the recession. And before then, firms realized they could pay lower wages. And now these two lines here, where you can see there's arrows pointing lower wages, these are the new ISO profit curves. So to begin with, or I say to begin with, so if we look at the point B, right, the disequilibrium point, we can see that producing a quantity of output Q star and a price P star, this is no longer leading to the firm maximizing their profits. Why not? Because this ISO profit curve is certainly not kind of at a tangent to the demand curve, right? So this is not the profit maximizing price and quantity. In fact, the profit maximizing price and quantity would actually be back at this higher level of output Q double star. And so actually, after the firm have lowered wages and this changes the shape of their ISO profit curves, especially the marketing department, would realize that to maximize profit, they would actually want to lower prices. And this lower level of prices would mean they need to hire more workers. And that's actually going to bring us back to the initial equilibrium, point X, right? So them lowering their prices is going to get us back to our old level of employment, lower prices, more quantity, more workers, and we're going to get back to our initial level of employment X. However, really, really key thing there is we have this, like one of the first steps in this happening is that the firms were able to lower the nominal wage. Now, in reality, in the real world, will firms be able to actually do that? Will workers accept a lower nominal wage, which then allows for a lower price and then this kind of increase in output and then more employment? The reality is possibly not. So there is a second possible solution. And the second possible solution is that the government potentially steps in. And so that's what this second diagram shows us. So again, imagine we've had this recession, and as a result of the recession, the firms sort of now realize that, well, actually, they could get workers to accept and put in effort at a lower wage, but actually maybe now there's some resistance to this lower wage. And the government sort of knows this. They don't want firms cutting the nominal wage because they don't want the workers to be unhappy, because then maybe they won't vote for the government. So what the government decides to do is they decide, well, another way to get us back to this higher level of output without the firms having to lower wages and then lower prices is, what if the government steps in and actually tries to alter the demand for the firm's product. And so the government could step in, increase its spending, boost aggregate demand, and therefore for every firm's demand curve, shift them rightwards or shift them outwards. And so that's what you can see happening here. We have this like low demand, and then the government steps in and shifts it outwards, as in at every price, there is a greater level of demand. And you can see that therefore is going to allow for an equilibrium, because now the demand curve is shifted out. It's going to allow for an equilibrium here at point X, where the firm is producing a quantity Q double star, and that higher level of output means more workers employed, and it gets us back to that equilibrium. So those are two ways that when there's a change in the level of unemployment as a result of a recession, those are two ways we can get back to that initial equilibrium. One is the firms cut wages and then cut prices, and therefore can increase output and get the workers back. Or the second is where the government steps in and actually does some government spending to boost the demand for firms' products, and that can get us back to our equilibrium as well. So that's the first example of how we can use this labor market model to think about what happens in a recession. Second thing we're going to have a look at is how we can think about calculating a Gini coefficient based on this sort of labor market model. So I'll go into that in a little bit, in a second. I'm just going to take a quick pause before I do. Okay, so the next thing that we're going to look at is how we can use this idea of like this labor market model to think about how we might work out a Gini coefficient for this sort of economy. So if we start by looking at the diagram on the left-hand side here, we can see we've got an equilibrium here at point A, where we've got 80 workers employed, and we see the total number of the total labor supply, the total labor force is made up of 90 workers. And we've got 80 who are employed, and they're employed as a real wage of 0.6. So what we're imagining here is that the average product of labor, the sort of total output per worker is an output of 1. And of that value 1, the workers are getting 0.6, and therefore the owners of the firm are getting the remaining 0.4. So what we then do is translate this into one of our Lorentz curve diagrams. So you can see we've got our black line here representing the perfect equality line. And then on the x-axis, we see the first 10 people, they they're unemployed, and so they have no income, right? That 10 is coming from this gap here between the 80 and the 90. Then we have the 10th to the 90th person. Those are the people who are employed in the labor market. And if you add all of their income together, it's going to bring us up to 60% of the total income, because they are getting 0.6 out of 1 for every unit of output that's sold. And then the final part, these last 10 people, and they're not coming from this diagram. So what we're imagining is that there are 10 further people who are the owners of the firms, and they are getting the profits, right? They are getting that remaining 0.4, that remaining 40% of the value of every unit of output. So what I'll just quickly run through is, how does this lead to a Gini coefficient of 0.36? Well, we're going to calculate that in the way that we would use any of these diagrams to work out a Gini coefficient. And the number of people is high enough that we don't need to worry about like the, like adjusting the kind of A over A plus B formula. So we're going to think Gini coefficient is A over A plus B. So A plus B, that is the area under the perfect equality line. And in that case, in this case, that's a triangle with a base of 100 and a height of 100. And so the area of that triangle would just be, oh, bad equal sign, will be 50 times 100, so 5,000. Now I could kind of convert these all to ones, but I'll use the numbers that are on the axes. So 5,000 there. And then what I'm going to do is work out, now the area A, I believe, is this blue area here. So what I'm going to do is actually work out the white area and then subtract that away from like the total area. So this area here, so we've got a triangle with a base of 80 and then a height of 60. So the area of that triangle will be half the base times the height. So that's going to be 40 times 60. So that's going to be 2,400, that area in there. Now I'm going to make a rectangle here. So the area of that rectangle is going to be 10 times 60. So that's 600 in there. Hopefully this is all going to work out. And then this area in here, so base times height divided by 2, the base is 10, the height is 40, so 10 times 40, and then divide that by 2. So that area there is 200. Okay, so if we sum all those together, the 200 plus the 600 plus the 2,400, so that means this entire white area is making up 3,200, which means the blue area in here, which we label A, has got to be the difference between the total, which is 5,000, and this white area. So that's going to be 1,800. I think, therefore, I'm now safe that the Gini coefficient is therefore going to be 1,800 divided by 5,000. And that, hopefully, yes, it does give us 0.36. Okay, so nothing kind of different there about other ways we've done these Gini coefficient calculations, but this is how we can, I suppose, construct one of these diagrams on the basis of this labor market model. All right, so the next part, the next kind of scenario we're going to think about is going to be a scenario involving immigration. But again, just before I go into that, I'm just going to take a quick pause. Okay, so the next scenario that we're going to use this model to talk about is what would happen if there was some immigration. So we're again going to start off think about being in an equilibrium, and that's going to be at point A. So we can see this curve here, that's the wage setting curve before immigration. Here's our price setting curve. So we're at point A. Then suddenly there's this burst of immigration, and you can see we go from having a labor force before immigration of 5 million workers, and then after immigration of 5.5 million workers. And what that means is there's now suddenly more unemployment, right? Because we're assuming these workers come in without any jobs or anything. So there's more unemployment. And the U's here show us that. So initially, before immigration, the gap between the number of people who are employed, which is 4 million at equilibrium A, and the labor force before immigration, which is 5 million, you can see that that gives us this equilibrium level of unemployment U. But then suddenly when the labor force expands, you still only have 4 million people employed initially, but now all those people, U, plus those extra immigrants who are now all unemployed. So what impact does this have? Well, now that there is a higher level of unemployment, right, and workers know now there's this higher level of unemployment, that is going to cause the wage setting curve to shift downwards, because now at every level of employment or unemployment, workers know they face more competition. And so they are going to accept lower wages to take a job and put effort in. And so the whole wage setting curve shifts downwards. But at the moment, we still have 4 million people employed. And so now we're at point B, right? Firms have lowered the nominal wage and they've lowered the nominal wage, and they've kept maybe the price at the moment the same. And so lower nominal wage, higher price brings that real wage down. And so we're now at this point B with 4 million people being employed. But what's going to happen next is, now that firms are paying a lower nominal wage, that's going to change the shape of their isoprofit curves. And it's going to mean that they could change their price and change their price and change the level of output and move it to a different place to get maximum profits. And because we assume firms' only cost is labor, right, and the cost of labor, the wage has gone down, they can also bring their price down. But as they bring their price down, if the demand curve is unchanged, they need to increase the level of output. But to increase the level of output, they need to hire more workers. And so we then start to shift along this new wage setting curve, because as firms hire more workers, then the level of employment goes up. But on this new wage setting curve, to get that level of employment to go up, on this new wage setting curve, as the level of employment goes up, we can see we need the wage to start going back upwards. And in fact, the real wage is going to go back up and up and up until it gets back to the level that it was before the immigration took place. And so our final equilibrium here is back at the same real wage level, now with 500,000 extra workers employed, and back again to having 1 million people unemployed. So overall, it seems like the impact of immigration in the end is kind of neutral, right? That we get back to the same real wage level with the same unemployment level. But what we got to take into consideration is there was a period of time where actually the real wage had dropped and the level of unemployment was higher. And so maybe that period of time would be not a very nice one for the domestic workers. But like in the end, the impact is neutral. It hasn't made much of hasn't had an effect. So that's how we can think about the impact of immigration. The next situation we're going to think about is what happens if we introduce unions, trade unions, into this scenario. Like, what would be the impact of trade unions on this labor market model? So we start by thinking about what is that going to do to our labor discipline model. So we can see we've got our workers' best response function, their best response curve here in red. And if there's no union in existence, then what the firm's going to do is choose point A here, because that's going to give them this ISO cost effort line, nice steep one, where they're minimizing their cost of effort per hour from their workers. But what if the wage isn't determined purely by the firm kind of coming along and saying, this is how much we'll pay you, worker? What if actually there's a union that this worker's part of, and the union sets the wage, and the union says, this is going to be the wage right here. So, well, what does the firm do? Well, from their point of view, they're thinking, well, if that's the wage, then we just have to, we're going to choose this point right here, because this is the steepest possible ISO cost effort line that we can get. This is us minimizing our cost if we have to pay this wage. Let me say it one more time. This is minimizing not cost, but the cost of effort per hour, if the wage has to be this level right here. So what's the impact of that on the wider labor market model? Well, let's scroll down. And okay. So what we see happen is, right, let's kind of start off. We're at point A, wage setting curve when there's no union. So this is kind of our standard equilibrium. And now what's happened as a result of the union getting involved is we can see at this particular level of unemployment where the worker has this best response function, now the wage has to be higher, right? So the wage to get the worker to actually work has to be higher. And we can imagine at different levels of unemployment, where the best response function is shifting to the right and like getting lower, or shifting to the left because there's more unemployment and kind of stretching upwards, because the union now is involved in setting the wage and they're going to want to set a higher wage. The whole wage setting curve is going to be higher, because now with unions involved, they're going to demand higher wages than they could, but the higher wages than if there were no unions. And so the effect of that is at every level of employment or unemployment, workers are now going to want higher wages in order to accept jobs and do those jobs. So what does that mean? Well, you can see it means that the wage setting curve has shifted upwards. Now, if the price setting curve hasn't changed, if nominal wages if real wages are still the same, we can see that the equilibrium now is no longer at A, it's at B. And so what's happened in this equilibrium? Well, in fact, real wages have stayed the same, but there is now a lower level of employment that actually the introduction of a union has not had an effect on real wages. They're still the same. All it's done is decrease the level of employment. So that seems to paint a quite negative picture of having labor unions. However, that doesn't necessarily have to be the case. And what we're going to do now is introduce another idea, another possibility, which is that if there is a good relationship between the unions and the firms, that this could actually encourage workers to increase their level of effort, right? So what's this diagram showing here? Well, we still got our union set wage up here. And we see that like on the old sort of best response curve, union wage would give us, this effort per hour. But what we're imagining now is that if there's a good relationship between the unions and the firms, that the employees would kind of see this positive relationship and actually be willing to put in more effort at this higher wage. And so the best response curve we see is shifting upwards, right? At every wage, they would put in more effort. And at the union agreed wage, they'd actually put in this level of effort, D. And so this is really good. This is certainly better than when you introduce the unions, certainly better from the firm's point of view. And just to kind of show why, because remember that before, right, the firms kind of had to, because they had to pay this higher union wage and they were going to choose point C, they'd get this ISO cost effort line. But now that workers are putting in more effort per hour at every wage because they're happy about this negotiation between the unions and the firms, the best response curve stretches upwards. And now at this union wage, firms get a higher level of effort per hour. They get this effort D, which means they can actually achieve this ISO cost effort line, which is steeper and therefore means that it is a lower cost of effort per hour. So this seems to be really good. Now, what we should point out is that actually in this diagram, that things would still be better off from the firm's point of view if there was no union whatsoever, right? Because they could actually be back at this point E, which is an even steeper ISO cost effort line, which would give them an even lower cost of effort per hour. But this, what we call the union voice effect, has improved things from when you introduce the union and there's no sort of bargaining, there's no sort of good relationship. So what's the consequence of this? Well, we can't know for sure, because how much of an impact is this like union voice effect going to have? But I think in the next diagram, we kind of like we make a particular assumption. So we make this assumption that the union voice effect is stronger than wage bargaining. So let's talk about what does that mean. So to start off with, I think let's look at the wage setting curve where there is no union, okay? And we got our price setting curve, and so our equilibrium is at this point X right here. And so we've got a level of employment N star, and then a real wage over here that let me call little W star. Now, what if we introduce the union, and the union like demanding higher wages? Well, like we saw before, that's going to shift the wage setting curve upwards, and that would actually lead to a new equilibrium where the real wage is actually not changed at all. I'll call that Z, but there's a lower level of employment, right? But we assume now that we also introduce this union voice effect, this like bargaining between the workers unions and the firms, which workers are really happy about, and that induces them to put in more effort per hour. And what that actually means is that from the firm's point of view, now that workers are putting in a greater level of effort per hour, that means firms can actually lower their costs again, and lower their costs so that the real wage they're actually paying workers comes down, and it actually leads to the wage setting curve actually shifting downwards. And so the wage setting curve shifts downwards enough that actually the new equilibrium is going to be at this point Y, where the real wage in this equilibrium is the same as it was before all of this like extra union stuff, but the level of employment is actually higher. Now, this doesn't actually match up perfectly with the diagram above, right? The diagram above would actually suggest that the final wage setting curve, where you have unions bargaining for wages, but this higher level of effort per hour, that would actually probably end up with a wage setting curve somewhere around here, where we would still end up with the same real wage, but actually a lower level of employment if there were no unions or nothing whatsoever. And the big assumption here is we're assuming that the union voice effect is much stronger than the wage bargaining effect. That the idea being that that extra effort per hour, because of the union voice effect, is so big that it actually allows firms to bring their costs back down, and therefore lower and therefore actually achieve this point with a higher level of employment. So what would actually happen in these circumstances, we can't know, but this is how we could use the model to actually think it through. So I think there's one final scenario to look at. And okay, so that's what would happen if there is a higher level. Okay, so the last scenario to look at is what is the impact of different levels of unemployment benefit on the equilibrium in this model. So again, where we can start here is thinking about the labor discipline model aspect of it. And so we see we've got unemployment at 12% for both of these best response functions, both of these curves. But The upper one here has low unemployment benefit. The lower one has high unemployment benefit. And we see the impact of the higher unemployment benefit is to change the shape of the best response function. So we see at every wage, there's going to be a lower level of effort per hour. And we also see a higher reservation wage. So that makes sense, because if unemployment benefit's more generous, then the kind of risk of losing the job is, the risk of losing your job is less costly. And so when you're working, you're going to put in a lower level of effort per hour, and you're also going to demand a higher wage in order just to take a job. So if we imagine at every level of unemployment, there is this higher unemployment benefit, we can see what that's going to mean is that the equilibrium hourly wage is going to be higher now at every level of unemployment. And what that's going to translate into is a higher wage setting curve, right? And that's what we're seeing in this diagram down below, that we've got this compared to here, this wage setting curve with low unemployment benefit. When unemployment benefit is high, workers now demand a higher wage at every level of unemployment. So what we see is that for a given real wage, say WH, a higher level of unemployment benefit will lead to this equilibrium at C with a 12% rate of unemployment. Whereas actually, if unemployment benefit was less generous and the real wage was the same, we would get an equilibrium at this point D. So same real wage, but lower level of unemployment, a higher level of employment. And again, this all makes sense if we think back to more generous unemployment benefit is going to mean workers are going to demand a higher wage to take a job and then put in effort in that job. And as a result, if real wage is at a kind of a constant level and workers are demanding higher wages to work, firms are going to employ fewer of them, and there's going to be higher unemployment. So that, I believe, is the last kind of example, the last scenario in this model. And that's the end of this second part of the Unit 9 summary. I hope that was helpful, and I'll leave it there.